Hello and welcome to Sarastas classes. Today we are going to solve some of the questions from quantitative aptitude. As we know that it is one of the most important portion in any competitive examination, and quantitative aptitude has not much conceptual complexity, rather than it requires your computing ability and memorizing capability. To solve such questions in small amount of time in huge number, the key skill is memorizing formulas and enable enable yourself for faster computing. For this, the most important portion is more and more practice. Okay, so let's try the first problem. The length and the breadth of the floor of a room are 20 feet and 10 feet respectively, and square tiles of 2 feet length of three different colors are to be laid on the floor. Black tiles are laid in the first row on all the sides, and white tiles are laid in the 1/3 of the remaining, and blue tiles on the rest. Then how many blue tiles will be there? So suppose this is the required rectangular portion of our floor with 20 feet by 10 feet. Here here uh, this portion is laid off by black tiles. Okay, and 1/3 of the remaining is laid off by white tiles, and the remaining portion is laid off by blue tiles. Okay, now we need to find how many blue tiles will be there. So first of all, we calculate the area of the floor. Which is equals to 20 into 10, results in 200 square feet. Now the area covered by black tiles, area covered by black tiles is equals to 2 into 20 plus 20 plus 6 plus 6, which results in 104 square feet. This is nothing but the area covered by these four rectangular portions. This rectangle, which is by length 20 and by breadth 2, it is also the same length and breadth, therefore we can multiply 2 with this area. And the next portions are these two rectangular portions with length 6 and breadth 2. Therefore it is 20 plus 20, which is we can write in this way also: 20 into 20 multiplied by 20, and 6 into 2 multiplied by 2. So 20 into 20 can be written as 20 plus 20, and 6 into 2 can be written as 6 plus 6. And if we take common these two, then this results in 2 into 20 plus 20 plus 6 plus 6, which is 104 square feet. Now area covered by white tiles is equals to 1/3 of the remaining area, that is 200 minus 104, which results in 96 divided by 3, and it is 32 square feet. Okay, now the area covered by blue tiles is area covered by blue tiles is equals to 96 minus 32, that is the rest portion, which is 64 square feet. Now area of one tile is 2 square, that is 4 square feet. Therefore number of blue tiles is 64 divided by 4, which results in 16. Therefore our required answer is 16. Okay, now let's check the next question. Two squares are chosen at random on a chessboard. The probability that they have a side in common is what we need to find is given 5 option. So let's try to solve this portion. Okay, suppose this is a pictorial representation of a chess with 64 squares. Okay, therefore the two different squares can be chosen in (64 into 63) ways. You can see this by box rule also. For the first box, for the first choice, we have 64. For the first one, we have 64 choice, and for the next one, we have remaining 63 choice. Okay. Now let's check the favorable cases. For each of the four corner squares, the favorable number of cases is 2. This is a corner square, this is a corner square, this is a corner square, and this is also a corner square. And the favorable cases are, for this square, the favorable cases are these two portions. So for each of the corner square, we have two favorable number of cases. So let's write it for each of the four corner squares. The favorable number of cases is is 2. Now for each of the 24 non-corner squares on all the four sides of the chessboard, the favorable number of cases is 3. The non-corner squares are these squares. In each side we have 6 of them. Okay. And for each square we have 3 choices. And the choices are, the first one is this, the second one is this, and the third one is this. Okay. For each of the 24 non-corner squares, for each of the 24 non-corner squares on all the four sides of the chessboard, the favorable number of cases is three. Now let's check the remaining ones. Let's check the remaining boxes. For each of the 36 remaining squares, the favorable number of cases is 4. Suppose this is one of the remaining box and the favorable cases are these 4 squares. So we have 36 remaining, and for each the favorable number of cases is 4. For each of the 36 remaining squares, the favorable number of cases is the favorable number of cases is 4. Thus the total number of available cases are thus the total number of favorable cases is equals to 4 into 2 plus 24 into 3 plus 36 into 4, which results in 224. Hence the required probability is equals to 224 divided by 64 into 63. Okay, and this results in 1 by 18. Okay, so this is the solution of the next question, and the correct answer is the option 3. Now let's check the last one. In an examination, it is required to get 540 marks out of aggregate marks to pass. A student gets 432 marks and is declared failed by 9% marks. Then what are the maximum aggregate marks a student can get? Now 9% is equals to 540 minus 432, which is given in the question, which is equals to 108. As the pass mark is 540 and the student get 432, and it is also given that it is declared that he failed by 9%, therefore 9% can be written as 540 minus 432, which is equals to 108. Therefore 1% is equals to 108 divided by 9. Hence the total aggregate means 100% marks is results in 108 divided by 9 into 100, which is equals to 1200 marks. Okay. So that's all for today. To know more about quantitative aptitude, you can call us or just drop a message at 9836748225756 or 9836793076. Okay, or you just can check our website, which is www.sorosesclasses.com.